As all of you know, the today's agenda of this webinar is automotive communication protocols. So we were there at the introduction part of automotive communication protocols. So as name looks bigger, but it's actually it's a very simple concepts. So in this webinar, you'll understand what are the protocols we used in automotive industry and why we use it and what's the advantage of them, where we use it, and what if you learn about them, then how you can use that knowledge in your job or in your interviews, anywhere you can use it. So let's go right away to next slide. So here is, okay, let me go back. Okay. So here is the table of content. So as usual, we'll start with the introduction of it. Then there is an evolution of protocols. Evolution means how the protocol started from the very beginning. What was the beginning of the protocol, and now what is the advanced state of protocols. Then we have next point is types of communication protocol, where we'll understand various types of protocols which we use in automotive industry. Then we have basic rule of any communication. So here I will introduce you about communication rules, which will be generically followed in every communication protocol, so that you will understand how in general protocol works. Then we have some example of protocols like CAN, LEAN, FlexRay, MOST, Ethernet. Then we are going to see use of protocols in automotive industry. So how we are going to use them in industry, and at the last, job opportunities. So here is the introduction about it. So first it will be what is a communication protocol. So all of you know protocols means set of rules. You might would have been heard recently in Man Ki Baat by Prime Minister Manmohan Singh saying this is not our protocol to any chief minister do something. So that kind of protocols means set of rules. So in general, anywhere when you say protocol, it's a set of rules. We have to follow them. So in communication protocol means a rules, set of rules for the communication. So that if you want the communication to happen properly, then you have to follow this protocol. So that is communication protocol, nothing else. And what needs to be communicated, as all of you know, when communication comes in picture, there is always a data. There is always information which should be communicated. And you know, this is the era of information era. And that's why communication is very important in this era. Let it be Facebook, let it be Snapchat, let it be any other mode of communication. Information is the key. And when information comes in picture, there's always a communication. In which mode you do it, that's irrelevant here, but the communication is important in next. Now we know 5G is going to come, so that is another communication. Okay, so going further, so why communication protocol, why we need a communication protocol? I'm only talking about automotive industry. We will be knowing anyway other industries why we need it as we go further. Anyway, I'm just focusing on automotive industry. So you can see left side picture. Earlier in cars or something, we used to use wires to transfer data, to transfer signal. Data means what? Signal. Earlier there used to be signal, square wave, sine wave, whatever the signal, analog signal, digital signal. We used to transfer them via wires, and these wires used to be so many in the car. It used to be a tangle, it used to be short circuited, it is too very hard to maintain it. It's a problem at that time to handle each and every signal, and to transmit that signal only using one wire dedicated to it. So it is a problem. So that's after this problem arises, then engineers thought, okay, shall we reduce this wire? Then comes in picture communication protocol. So they developed the communication protocol, they set up the rules because by defining those rules, they have decided, okay, everyone should follow these rules, and we can transmit the data from one ECU to another ECU. ECU is nothing but electronic control unit. So it is just a microcontroller which can transfer data from one controller to another controller. So in between the transferring, they have decided the rule. So this whole process makes automotive engineers' life simple. Who is developing it, who is maintaining it, mechanic, everyone in the chain will be very. It will be very easy for them to debug it, to understand it, to identify the problem, and to solve it. Everything is easy in this whole automotive industry chain when communication protocol introduced. So going further, as I told you, there are basic rules of any communication. Take an example of human communication. When we communicate with each other, we need same language. We need some medium to communicate with each other. We need some kind of response from the listener so that we understand, he understands it, he is listening it. So this is a kind of aspects of the communication. These are the factors which makes communication proper. If you see someone is not replying to you, then you might be thinking he is not listening to me. He at least should not, or should say yes, or something acknowledgement should be there. So this kind of aspects are important in any communication. Let it be very basic communication or very advanced. There should be these things which has to be taken care of any communication. So like in human interaction, same happens in issue interactions. So they have set of rules which we should follow, or which they have implemented. They need it for the communication to happen properly. So here you can see the table where I have pointed out some aspects. Here you can see mode of interaction. Now we have taken example of human communication. I am communicating with you through English language. You can understand it because you know that language. If you don't know that language, then I have to communicate with you different. So same goes for the between the ECU. They should communicate with the same language. Like if they are going to communicate with using CAN protocol, then both should understand CAN. If they're going to transfer data using lean protocol, then both should understand the lean protocol. So that's what a language or protocol is important. For us, language means nothing but a set of rules. Like we should have grammar, we should have verb, we should have noun. So these rules we follow. That's why the communication happens properly within us. So same kind of rules, protocol rules are defined between ECU communication. Next, we need a medium. Now for us, medium is sound. We can hear it through ear. So same they have using wire. So ECU communication needs a wire to transmit. Advanced protocol, there is an advanced protocol which is I'm just focusing on automotive. So there are advanced like 5G, then apart from that Wi-Fi and all those are advanced. Those I am not focusing because they are not introduced currently in automotive industry. Next is speed. Now I am taking a break in between talking to you, and I am keeping my speed in control. I am not going too fast or too slow, so that you can understand it. If I am going one way fast like a train or metro, you will not understand what I am talking about, and you will not process it. So when processing part comes in between, we need to be in the same speed. Same rules apply in issue communication. The data which is transmitted has to understand by another ECU, so that they should be in same speed to understand the data. Otherwise there will be a miscommunication. They won't understand it, they won't sync it properly. Next is acknowledgement. So when I'm saying it now, I know we this is one way training here, but in general ECU communication or in human interaction also, we need a feedback from someone. If I am telling you some story, then at least you should nod it. Okay, I'm listening. So same kind of feedback is requested in ECU communication also. If one ECU is transmitting some data, he needs some acknowledgement He's waiting for the acknowledgement, like communication is done, it's happened properly. So that's what acknowledgement or feedback comes in picture. So these are the basic aspects you should take care in every communication, and these are the very basic things you should be knowing. So here is one example where you can see how a CAN communication, specifically this is a CAN communication, and you can see here is two ECUs. One is ECM, means engine control unit, and ICM means instrumentation control management. ECM is engine control management, and instrumentation cluster management. So these two ECUs, if they want to communicate with each other through CAN protocol, first of all they should know the CAN protocol. ECU knowing a CAN protocol means what? They should have CAN implemented in them. CAN.c file, CAN rule should be implemented them. They should know those rules, how to transfer data. So when I use CAN bus to transmit this data, you can see this ECU is sending a data of temperature and fuel tank to this ECU, and instrumentation cluster will display that information on our dashboard. When you enter in a car, you will see one panel, instrumentation panel. On that, you will see many gauge, warning indicators and all. So these indicators comes directly from another issue. So this instrumentation doesn't actually check fuel tank level or temperature sensor. It gets that information from another issue through any protocol communication, and he displays those information on the instrumentation. So this is how in general communication works in ECU. They takes any important data from another ECU, and they do processing on it. Now question might arise, why not one issue can do this both things? We have divided the issues based on their responsibility. If engine control management is going to control engine, then he should do only that things, he should not do other things. That's similar, if instrumentation cluster management is going to display something on panel, then he should do only those things. So that's what we have divided the work, so that it will be very feasible. Same thing happens in our team also. We divide works to different people, you do this, you do that, and we do the work very fluently and sequentially. So this is the one example, and this is just a diagram of software level, how it happens. SWC means software component. It's just one part of the software. Then next question can comes into your mind, like, can I build my own communication protocol? So answer is yes. Why? Like I have told the basic aspects of it. If you want to build one protocol, you should take care of speed, you should take care of feedback, you should take care of more rules. If you have thought about all those aspects, and if you think your protocol is better than existing, or even if it's not better than existing, if some kind of advantages are there, then you can build it, and you can display, you can show it, okay, I have created one protocol, please use this. If that is good, then everyone can use it. So going further, here is a one diagram where you can see how protocol has been developed from the past. So the first protocol which was developed was CAN here 1985 by Bosch. From that onwards, protocol started developing by one, and there are some advantage, disadvantage of each protocol depending on their speed, depending on their cost, depending on their how much error detection they do in communication. So these are the evolution happened from the 1985 to 2015, and still it's going on. So it's a continuous process, still new protocols being introduced. New OEMs, or OEMs means equipment manufacturer, original equipment manufacturer. Those guys will develop their ECUs or car depending on those protocols. They decide it, and they use some kind of protocols so that they can have communication between two ECUs. So here is just the example to show you those development of protocol. And next is the types of communication protocol. Now, I have taken earlier example of human interaction. So in human interaction, what are the types of communication protocol? You can tell, okay, I can do communication using call, I can do with SMS, I can do with video, I can do with social servicing, social sites, or radio, anything like that. So these are the types of communication protocol depending on their advantage, depending on their speed, medium. These types has been there. Similarly, in automotive also we have types depending on their different aspects. So you can see first is asynchronous and synchronous. Asynchronous means it's not synchronized, and synchronous means synchronized. It's a very basic definition. Synchronized means what? There will be a shared clock, or there will be a crystal clock. Any one of you, if you have electronic background, or if you know the microcontroller, there's a clock, system clock in it. The clock is which we can synchronize to it. Asynchronous means there is no clock sharing, or there is no same clock shared between two ECUs. So if you don't share that, it's like communicating between me. I know the English, but I'm trying to communicate with a French guy. So there is no synchronized between similar clock here. So similar, like we have another type, event triggered and time triggered. So event triggered is similar to asynchronous, like it can happen as soon as event occurs. And time triggered is a periodic. So every some periodicity, this communication will happen. This and next is single master and multi-master. Single master means within a protocol, within that network of ECU where data is shared, one master ECU will be there who will control that communication. Like in our school, teacher used to communicate. He is a master. He will control the communication. He will only ask the question. He will only control the questions and answer. He will only teach it. Similar here in the training, currently I am a single master. I am only giving data to you, and you are just listening it. Multi-master is like, okay, it's like we have some group discussion. So where everyone can participate at any time. Multi-master is an example of CAN is also example of multi-master, where everyone can participate in communication and they can transmit a data. Next is high speed and low speed. This is depend on the speed of the communication. So as normal example, you can take it's like 2G, 3G, or 4G. So if it is high speed, then communication will happen faster. Low speed is a very low speed having data communication. These are in general types of protocol, and they are defined with their aspects. Going further, you can see the detail of it, asynchronous versus synchronous. As I told you, a speed of asynchronous will be slow, they'll be less reliable because they can come between any time. We don't know when data will come. Another issue will be waiting for the data, but he doesn't know when the data is started and when data will end. So that is a less reliable. Not required synchronization, not required means we are not sharing any clock, we are not synchronizing with them, we are dependent of each other. So that's why whenever data is coming, we are just sharing it. So one issue will just share the data as soon as data is available. Cost is cheap because we are not using any synchronized mechanism. The cost is cheap. Time of interval, as I told you, it can be transmitted any time. And complexity becomes highly complex because we need to as it becomes less reliable, we need to add some mechanism to make it more robust. So that's what it gives a problem for us. Synchronous adds opposite to that. You can see all the aspects. It's a fast, it's highly reliable. Why it's a highly reliable? Because they have the periodicity. We know at this time we are going to get data. At 1 millisecond, we are going to get data. At 10 millisecond, we are going to get data. So we know the data is going to come. So that's why it's reliable. Synchronization is required because we need to have that periodicity. We need to fix a periodicity between two ECUs, like the data should be coming between two ECUs with a 1 millisecond periodicity. So at every 1 millisecond, data should be transmitted, and this periodicity synchronization should be there. Cost is high because there should be a mechanism implemented, hardware and software for the synchronization, which adds up the cost. Time of interval anyway constant, and complexity is easy. This complexity is for the developing it. So this complex, once you develop it, it's easy to handle it. So going further, we have event triggered versus time triggered. Now here you can see the example of event triggered and time triggered aspects, where you can see event triggered is slow because we have to have add many other mechanism so that the communication should happen robustly. Because adding those mechanism, it becomes slow. And in time triggered, it is fast because we don't need to worry about any other things. We just have to transmit the data, and it will be very fast compared to event triggered. Media access, CSMA means carrier sense multiple access. Whoever having electronics background knows about it. The carrier sense is like a data will be carried we using a carrier signal. So the data is carried there, and the multiple access means multiple data, multiple it's used communication node can add the data there. Here the media access is TDMA, time division multiple access. So the data is divided with the time. So every periodic data, the periodicity, the data will be transmitted. Clock synchronization anywhere required. Here event trigger not required, time trigger required. Cost is cheap and costly. Complexity is again high and easy. As you can see here, the event triggered is more or likely asynchronous. Time triggered is more or likely synchronous. So it is just how we define at which aspects we define this communication protocol. We just gave the name. Okay, you can take a one normal example of event triggered is like any event occurs asynchronously, like, okay, consider lockdown declared. It is asynchronous. We don't know when they will declare, doesn't know how much time they will declare. Time triggered, we know, like, okay, 9 o'clock there will be some prime time news. There will be a news at the 9 o'clock every day night. So that is time triggered. Going further, single master versus multi-master. So as name suggests, number of master in single master is only one. He will control the communication, and in multi-master at least two or more than two. So as I told you, CAN is example of multi-master and lean is example of single master. So you will get to know more that what is how communication differs between single master and multi-master. As I gave earlier one example of group discussion and the lesson in our teaching classroom, which master our teacher takes. Then control of communication, anyway I told master issue will control it, and here in multi-master all master issues can control the communication. Scheduling, scheduling means the like consider there is a scheduling required in your class. This time to this time this subject is going to be taught. After that, 10 to 11 geography will be there, 11 to 12 mathematics will be there. So this scheduling is required by should be done by master. But here in multi-master there is no requirement of scheduling because everyone will control that communication.